I'm Janavi Malhotra.
And I'm Neha Zahir. We're grade 11 students from Milton District High School.
This is our project, Home Assistance Robotic Transport, aka HART. We wanted to explore the means of the rapidly increasing industry of robotics by creating and programming a robot, specifically an assistive robot, that is able to help the elderly or disabled with tasks that may require physical effort.
Our idea for HART came from thinking about the world as we know it today and the type of technology that we have, such as cars, computers, MRI machines, and other assistive technology that made such a huge impact on our society. We wanted to help contribute to that impact a little bit by making a robot that would be able to help someone with tasks they may or may not be able to do.
The making of HART was done at our homes over the course of about 3 to 4 months, and the base of HART was made using a Freno 4WD card kit.
HART's features include a storage compartment tray, 2 compartment trays at the side, and 2 pull-out trays that would be used to help push larger or heavier objects. HART is controlled via RF remote and receiver, the remote having a joystick that helps him move forwards, backwards, left, or right.
This is an example of how HART uses his pull-out trays to push objects.
We also made HART square-shaped to allow the user to be able to park him in corners to maximize space efficiency.
We used an Arduino software with C++ coding, specifically because in the robotics industry, C++ is widely used and very important to know. It helps to maximize the productivity to performance ratio and also contains many essential hardware library functions that are needed in robotics. We also decided to use an RF or radio frequency remote rather than an IR infrared remote, simply because the transmissions would be able to travel much easier through HART's body to the RF receiver, which is plugged into the control board. This would not be as easy with the IR remote.
In the making of HART, there were of course some difficulties that we ran into. For example, his back left wheel socket was chipped, which meant the wheel just kept popping off and wouldn't attach to the motor. To fix this problem, we just replaced the wheel entirely.
We also originally planned to have HART hold a large tray in the front, but we decided to switch it to 2 smaller trays on the side. We did this because having a large tray in the front as well as the storage compartment would have caused a weight distribution imbalance, which would cause HART to topple over every time he would break or stop.
Despite these difficulties, there were so many things we enjoyed about the making of HART. For example, his construction and assembly were especially fun for us since we had full creative control over what he'd look like, what he'd hold, and what he'd do. We also really enjoyed learning about robotics and coding and how it just ties together in our world.
Our next steps for HART would be to add and program a line tracking sensor to the base of HART. The idea would be that the user would be able to implement a line pathway throughout their home to places they often visit in their routine, and HART would be able to travel that line without the user having to constantly use the remote. This would create a routine for HART and also help the user save time.
To add on to this, we'd add a controllable arm to HART, which would help him remove and pick up things from his tray, and this would allow HART to be able to make those routine trips, as mentioned earlier, without the user having to come in every time.
Overall, HART is successful in his ability to help out with physical tasks throughout the home. We thoroughly enjoyed working on this project, and we're very happy with our outcome of creating a robot that is able to help people if needed.